Now explaining some functions. First function is identity function. Say definition of identity function is that here we are taking R, it is the set of all real numbers. R is the set of real numbers, then a function f whose domain is R, codomain is R. A function from R to R defined by fx equal to x. Whatever you keep in this function, it keeps element unchanged. Here whatever we keep in this function, it comes from domain. This x comes from domain, and output, it is always in codomain. So a function keeping x as it is without any change, this is said to be the identity function. It is said to be an identity function. So here, say as for example, what is happening? If I keep here 3 is from domain, so f of 3 is 3. If I put here minus 3 by 2, f of minus 3 by 2 is minus 3 by 2. If we keep here root 3, f of root 3 is root 3. So this is identity function. This function is denoted as identity function on set of real numbers. This is from R to R, so put here R. If here it is given n to n, then keep here n. If here a z to z is given, then put here I z. Whatever is here a to a, so put here a. That is identity function on a. So this is identity function on set of real numbers. Say its graph. Its graph is this is x-axis, this is y-axis. X, that is input, this is output. Input comes from domain, so domain we represent on x-axis and codomain we represent on y-axis. So here when we take x equal to 1, taking x equal to 1, f of 1 is 1. If x equal to 2, then f of 2 is 2. If x equal to 3, then image of 3 is 3. If x equal to minus 2, then image of minus 2 is minus 2. So these values we take from x-axis. So these are x coordinates. X coordinate 1, x coordinate 2, x coordinate 3, x coordinate minus 2. And these are y values. Images we represented by y. So y is 1. So image of 1 is 1, image of 2 is 2, image of 3 is 3, image of minus 2 is minus 2, like this. Now these points we are representing on this graph. Image of 1 is 1, so 1 1 is a point on this graph, 1 1. Image of 2 is 2, so here say this is 1, this is 2, this is 3, like this. Here it is minus 1, minus 2, plus 1, plus 2, plus 3. This side x values minus 1, minus 2, minus 3. Now showing these points, point 1 1, this is 1 1, then 2 2, so this point is 2 2, 1 1, 2 2, 3 3, 3 x3 y3, so 3 3. If you put here 0, image of 0 is 0, so if you put 0, then image of 0 is 0, so 0 0 is also a point. Minus 1, image of minus 1 is minus 1, image of minus 1 is minus 1, so see, image of minus 2 is minus 2, image of x is itself. So we are getting points whose x and y coordinate are same, and these points are in first and third quadrant. Joining these points, here we are getting a straight line. So this is said to be graph of fx equal to x. It's a straight line dividing first and third quadrant into equal parts, and this angle is angle of 45 degree. So this is graph of this identity function fx equal to x. Now second function we are taking constant function. Constant function, see, in the name of this type of this function, in this name, meaning is clear. Here let R be, again we are taking R, it is the set of all real numbers. Then a function f from R to R, fx equal to c, where c is any constant, a real constant, it can be any real. This function is said to be identity function. Sorry, it is said to be a constant function. This function is said to be constant function. So here you can see that x is a variable. It comes from domain. From this R, x comes. And c is a constant. It is any real. It belongs to R. This is fixed. As for example, say here, if I put here 1, or we say, I am putting here example, f from R to R, fx equal to 3. So this is value of c. This is value of c. Here I have taken c equal to 3. So this is a constant. It means image of any real belonging to R, it is fixed. Image of 1 is 3. Image of 2 is also 3. Image of 3 is also 3. Image of 0 is also 3. Take here any number. Image of -1 is also 3. Image of -2 is also 3. Image of 11/2 is also 3. Image of √3 is also 3. This is any real, any x. So x coordinate is a variable, it changed its value, but image means this is y. Image of x under y, so y remains the same, fixed. Means image of 1 is 3, image of 2 is 3, image of 3 is 3, image of 0 is 3, image of -1 is 3, image of -2 is 3. So graph of this function passes from these points. So if we take here graph, then see what is happening. X, this is y, origin 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, 4, etc. 1, 3. So x1, y is 3. This is point 1, 3. 1, 3. Then put 2, 3. 2, 3. So this is 2, 3. 3, 3. 3, 3. 0, 3. So x coordinate 0, y coordinate 3. This point has coordinate 0, 3. 0, 3. -1, 3. -1, 3. -2, 3. Means select any number. If you take 5/2 or 2.5, so if x is 5/2, y is 3. So 5/2, 3. 3/2, 3. Select any x. Its image is 3. This is fixed. Image is 3. So every point has y coordinate fixed 3. So joining these points here, we are getting a line parallel to x-axis. So this is graph of fx equal to 3. So here graph is a line parallel to x-axis. Here to understand this graph, I have taken c equal to 3. If c is 4, then it will be passing from 4. If c is -1, c is -1, then it will be passing from -1. So here line is always parallel to x-axis or horizontal line. So graph of this constant function is horizontal line. So this was about constant function. Now next is polynomial function. Polynomial function. See, here I am taking function from R to R. Fx equal to 3 plus 7x I am taking second example. F from R to R. These are from R to R. R is set of real numbers. For set of real numbers, slightly we differ symbol for R by this double line. Here I am taking fx equal to 4 plus 3x plus 5x square. Fx equal to, a function is from fx equal to, suppose 3 minus 2x plus 4x square minus 6x cube. See, here I am putting polynomials. This is a linear polynomial. This is quadratic polynomial. This is cubic polynomial. So if fx is a polynomial, then these are polynomial functions. Polynomial functions. So we can say definition that here a function from R to R, fx equal to a0 is constant plus a1 x raised to 1 plus a2 x square plus a3 x cube plus an x raised to n. This polynomial has degree n. So these are having this pattern. Say here this is a0 plus a1x. a0 is 3, a1 is 7. This second is of this pattern, quadratic. a0 plus a1x plus a2x square. Others are 0. So we can have polynomial with any degree n. Here n is non-negative. N is non-negative integer. Any non-negative integer. So say f from R to R, fx is a0 plus a1x plus a2x square plus up to an x raised to n, where a0, a1, a2 up to an are any constants. These are any constants and n is any non-negative integer. This should not be negative. Otherwise, this cannot be considered as polynomial. If we have any polynomial, then every term x must have non-negative power. Negative power is not allowed in polynomial. So this function is said to be polynomial function. So this is about polynomial function. Now fourth function is rational function. Rational function. A function, say if fx and gx are polynomial functions, then a function hx equal to fx upon gx, where say here fx is a polynomial function, gx is a polynomial function. So this ratio fx upon gx, it's a rational function. hx is equal to fx upon gx. This is said to be a rational function where gx is not equal to 0. It is said to be a rational function. We know that Px is a polynomial, Qx is another polynomial, and if we take its ratio where Qx is non-zero, then this is a rational expression. So this is same. This part is rational expression. And if we take this as a function, hx, then this is a rational function. As for example, here, suppose, here I am taking a function h. H from, say hx equal to, I am taking hx equal to x square minus x plus 1 upon x cube plus 1. So hx is x square minus x plus 1. This is fx. This is gx. It's a quadratic polynomial. This is cubic polynomial. So quadratic function, cubic function. So its ratio. Now this is said to be polynomial. It is said to be a rational function. But denominator must be non-zero. See, when this will be 0, if I put here if I keep minus 1, if we keep minus 1, then see what is happening. If I keep in this function, if I keep x equal to minus 1, so minus 1 square minus of minus 1 plus 1 upon minus 1 cube plus 1, that is minus 1 square is 1 plus 1 plus 1 upon minus 1 plus 1. So 3 by 0. And 3 by 0 is not defined. This has no value. We can't say a fixed number. 3 by 0 is undefined number. So in mathematics, whenever you get 0 in denominator, that means problem. So in this machine, if I keep minus 1, then machine is not giving any output. Machine is out of order. If you insert minus 1 in this machine, so machine doesn't allow minus 1. Machine allows only those input or raw material using which it can produce something. If it doesn't accept raw material, it will be out of order. So here machine is out of order. So this is not allowed. So in domain, we do not include minus 1. So here any number is allowed. See, problem is at only minus 1. There is no any other number for which this will happen again. It is happening only at minus 1. So minus 1 is the number that is problem creating number. So we are removing minus 1 from set of real numbers. So from R, remove minus 1. So this is domain. Any number you can take here. Domain is the set of numbers which are allowed to put in this machine. Codomain is R. So this is a rational function. It is a rational function. Then fifth type of a function is modulus function. Modulus function. Definition of modulus function is that, see, a function f from set of real number to set of real number. This is the machine. Put any x from domain. This machine puts number in modulus. So this is said to be modulus function. It is said to be the modulus function. So here what is happening, if I put 3, f of 3 is modulus 3, that is 3. If I put minus 3, then modulus of minus 3 is plus 3. So see here what is happening on this number. This is clear. F of 3 modulus 3 is 3, that is clear. F of minus 3 modulus of minus 3 is 3. Now see, this can be expressed as what this modulus does. See, this answer is 3. Modulus of minus 3 is 3. Now what this modulus machine does, how it removes minus sign. So we can understand this as that this modulus machine, what does it? Inside number is minus 3. Now modulus applies one more minus. If number is negative, then modulus applies one more minus sign before that number. So minus minus it becomes plus. So say here, this is positive. If number is positive, modulus keeps as it is. If number is negative, modulus assign one extra minus before that number. So finally the value is positive. So we can say that if x is positive, if x is positive, then modulus x is x. If x is 0, modulus of 0 is also 0. If x is 0 equal to 0, then also it keeps as it is. Put 0 or any positive, modulus keeps as it is. So mod x is x. Now I am putting here negative. This is x. This is x. See, this is x. So f of x is modulus x, and modulus x is minus x. If x is negative, then modulus x is minus x. Modulus always give positive, but if you keep any number negative in this machine, then what it does, this is x, so this is x. Same, minus 3, x, x. But before this x, it keeps one extra minus. So minus of x. In value of x, minus is visible, not in x. This is negative, so negative of negative is positive. Here, this is negative. This is negative. This number has negative sign. Whatever is here, same number is here. This number is negative. And before negative, a minus sign is applied. So negative of negative is positive. So this value is positive. This is obviously positive. So these are very important statements useful in mathematics. Very important statements. Now, graph of modulus function. See, fx is modulus x. If we put 0, then modulus 0 is 0. If we put 1, modulus 1 is 1. If we put 2, modulus 2 is 2. If we put 3, modulus 3 is 3. Now few negative numbers. If you keep minus 1, modulus of minus 1 is 1. If you put minus 2, modulus of minus 2 is 2. If we keep minus 3, modulus of minus 3 is 3. This is x, this is y. Fx equal to y. So x coordinate 0, y coordinate, this is y is 0. If x coordinate is 1, y coordinate is 1. Image of 1 is 1. Image of 2 is 2. Image of 3 is 3. Image of minus 1 is 1. Image of minus 1 is 1. Image of minus 2 is 2. Image of minus 3 is 3. So we are getting points on the graph. Few points are required to observe the shape of graph. Now see, here this is x-axis, this is y-axis, this is origin. Here 1, 2, 3, 4, 1, 2, 3, 4. This side minus 1, etc. 0, 0. This is a point on graph. 0, 0. 0, 0. Then 1, 1. 1, 1. Then 2, 2. 2, 2. Then 3, 3. 3, 3. So when x is positive or 0, y is same. So we are getting points on this ray. Here we are getting points like this. Now, when x is minus 1, y is 1. Minus 1, 1. Minus 2, 2. Minus 2, 2. Minus 3, then image is 3. Image of minus 3 is 3. So when x is negative, y is positive. Minus will be removed. So we are getting points in second quadrant. Joining these points, we are getting similar points. So here, joining these points, we are getting union of two rays. This is the union of two rays. This is 45 degree. This is 45 degree. Its graph is graph of fx equal to modulus x is the union of two rays dividing first and second quadrant in two equal parts. So this is graph of fx equal to modulus x. Now say, suppose we want graph of a function from R to R fx equal to modulus x minus 1. Fx equal to modulus x minus 1. Let us calculate images. See, if x is 1, put here 1. So 1 minus 1 is 0. Put x equal to 2. 2 minus 1 is 1. Put x equal to 3. 3 minus 1 is 2. Put x equal to 0. Put here 0. So modulus of minus 1 is 1. Put minus 1. So minus 1 minus 2. Modulus of minus 2 is 2. Put minus 2. Minus 2 minus 1 minus 3. Modulus is 3. Putting minus 3. Minus 3 minus 1 minus 4. Modulus of minus 4 is 4. Here this is x. This is value of fx. This is x. This is value of fx calculated by this formula. Fx equal to modulus x minus 1. Now to observe its graph, putting these points here, this is x-axis, this is y-axis, origin, here 1, 2, 3, 4, minus 1, minus 2, minus 3, 1, 2, like this. So image of 0 is 1, x0, y1, x0, y1, this point is 0, 1. Image of 1 is 0, this is 1, 0. Image of 2 is 1, image of 2 is 1. Image of 3 is 2, image of 3 is 2. Similarly, image of 4 will be 3. Image of 4 is 3. Image of minus 1 is 2. Image of minus 1 is 2. Minus 1, y is 2. Image of minus 2 is 3. Minus 2, 3. Image of minus 3 is 4. So we are getting points on this ray. Joining these points, we are getting union of two rays. Again we are getting union of two rays. Joining these points, here we are getting union of two rays like this. Now observe this two curve. This is shifted 1 unit on the right side. So when this is shifted 1 unit on the right side, this corner is shifted at this point, and you can see here it is. This corner is shifted at 1, 0. So say formula was modulus x minus 1. So putting here x equal to 1, this is 0. So at x equal to 1, on x-axis, a value at which function has image 0, at that point this curve has a corner. This is 45 degree. This is also 45 degree. So it is shifted on this side. Similarly, now see, if suppose you want graph of f from R to R, fx equal to 2x plus 3, modulus of 2x plus 3, graph of this function. See, what is the trick? Check for which x this is 0. So here hint is, for which value of x 2x plus 3 is 0. 2x plus 3 is 0 if x is minus 3 by 2. So on x-axis at minus 3 by 2, create a corner. So on x-axis, this is x-axis, this is y-axis. Here it is minus 1, this is minus 2, and here this is minus 3 by 2. At minus 3 by 2, this corner will be shifted. So this is the method to draw graph of modulus function.